Good morning, everyone. Welcome to another Saturday in the Rio Grande Valley. And today we're going to talk about First Tech Challenge Strategic Design. We have a great panel today of students here in the Rio Grande Valley and also some coaches that have joined us. There is not a formal agenda for this morning, but what we're going to focus on is specifically not into the weeds about game rules, but this is more about game elements and how to design and operate a robot for success on the competition field. As a reminder, first is number one priority is safety. So while you're brainstorming, you don't have to wear your safety glasses for this session, but please remember when you are working with your robot and using game elements, it's important that you wear your safety glasses. And if you're cutting any metals or doing working with sharp edges, please use gloves and other safety measures. For any other questions about that, please reach out directly to your coach that they will provide you guidance on that. So today's session is being chaired by a former First Tech Challenge and First Robotics competition student, Victor Menchaca. Victor came to the Rio Grande Valley from Hawaii and started at McAllen High School and was one of the starting members or founding members, I guess I could say, of the McAllen High School robotics team and is widely known as Zeus. Um, yeah, we're trying to retire that, but for now he's known as Zeus. He's a recent graduate of McAllen High School. He serves as our one of our first vistas here in the Rio Grande Valley. So thank you, Victor, again for your service in the mission of FIRST here in the Rio Grande Valley. He is a full-time employee-ish of FIRST Robotics. So with that, I'd like to turn it over to Victor.
All right, good morning, guys. Thank you all for joining us this morning. So first off, he kind of gave me a good introduction. My name is Victor. I'm a recent graduate from McAllen High School of 2019, and I'm currently attending the School of RGV for Mechanical Engineering. So real quick, we're just gonna go over and introduce our panelists. So we'll start off with Ethan.
Hi, I'm Ethan. I'm the lead programmer for 1273 Impulse. I go to McAllen High School, and that's me.
All right, Johanna, go ahead.
Okay, hi you guys. I'm Johanna Park, and I am the president of 12709 Legacy from McAllen High School. And yeah, that's me.
All right, Hugo, you could go next.
Hi guys, I'm Ugo. I am from the lead programmer for Team 12448, and I go to Veterans Memorial High School.
And now our shining star.
Hi guys, my name is Ismael. I am the team captain from Team 12448 from Veterans Memorial High School.
All right, great. So thank you all for joining us, especially our panelists. I know you guys just took in the time out of your Saturdays on kind of short notice, and I really appreciate everything you guys do for us. So starting off, we're just gonna talk about the game and so mostly the elements. So I have a bunch of rings right next to me, as well as the Wobble Goal. So starting off, I know a lot of you guys haven't touched it yet, but here's the ring. Let me make sure I have the manual open. And so it's exactly the specifications as included in the manual, about 5 inches with 3 inches in inner diameter. And it is very flexible. This is not a hard game object. It's very malleable. I'm applying quite a bit of force, but this is going to be nothing for a robot to pull apart. In addition, it's very easy to stretch. As you can see, it has a lot of deformation as I apply pressure, and it's very easy to twist. So this will not be a hard game object to pick up this year. If we compare a lot of them, they have a lot of, there's a lot of variation in density. So like, it's hard for you guys to tell, but this one requires a lot more force to twist. Now, upon twisting this, it does hold that shape a little bit. So take that into account when you guys are practicing on the field. You could definitely play with these and make sure, but just make sure you take care of them. I don't think these are gonna rip very easily, but these will definitely hold the shape if you hold them like that for a while. So just keep that in mind. They all vary. Like I said, like this one's extremely soft. But we have no tears, no rips. They're pretty consistent all around the board. The seam is going down the center. So be very wary of that. If you have any sharp edges on your robot, this is probably where it's going to catch it. We also have a seam on the inside. It's a little harder to see. Okay. So those are the areas we want to be real careful about. I don't think you're going to break the surface of this without digging into it very hard. And then let's move on to any questions on these rings yet from our panelists or anyone watching the stream?
Is it
No?
like a hard foam or like a very flexible plastic?
I would definitely say this is a foam. So if you guys did relic recovery in the past, those were foam cubes and they had a really just a foamy texture to the cube. This one has a very smooth texture. So it will be a little harder to grip compared to those cubes, but it's definitely a foam. It's not a plastic. It's not rubbery.
Yeah, we have a great comment from the chat that says looks like a stress ball. Yeah, it's I can see how students may do something that will cause damage to those. So just be very careful when you're making your shooter, because remember, inflicting any damage to the game elements are penalties. So be careful of that.
Absolutely. I think a stress ball is a really good comparison to what this feels like. I mean, I guess that's what I'm going to start using it for now. But it's really a tough object. It's really tough. I'm sure, I mean, I of all people will know how to rip this thing apart, but this is going to be a really robust object, and I think it'll mess up a mechanism before your mechanism messes it up. It's very strong. It's very tough. So moving on to our mobile goal, our Wobble Goal for this season. I have one here. It's the blue one. So this thing is pretty tall. Now, I can't guarantee this is exactly to spec as far as like everything down to the millimeter, but it's pretty big. It's very big. And it has a very small circle in the center of the base, and that does not keep it steady on the table. With no rings on this, I'll angle my camera a little bit. It still wobbles with nothing on it. I'm not moving the table. I'm not touching the table at all. And it's very unbalanced, very uneasy. So if you guys are picking this up and you drop it down, it will be wobbling for a while. So if you guys have mass on this, especially higher up, it's got a very high possibility of tipping. So just to give you guys a size comparison, compared to the ring I just had before, this is the ring. It's closer to the camera, of course. You have a lot of leeway when it comes to scoring this on the pole. There's quite a bit of leeway. You don't have to be that accurate. This little cap does add a little bit of a diameter to it. It's a little taller, or a little wider, excuse me, but nothing too significant. It's really just to protect the game object. This is rubbery. This is a hard plastic like they've used every season. This is all very solid though. You're not going to break this, but please be careful when applying force to it. So any questions on the basic Wobble Goal yet?
How
Yes.
heavy is it? Like around how heavy is it?
I'm not a scale, but
You're not.
I would, yeah, unfortunately.
Dang it.
But it's pretty heavy. It's not a light object. I can't even quantify it with the foam rings. So you'll definitely need a different manipulator to pick up the Wobble Goal versus the rings, assuming you want to pick these up fast. Just the rings alone, I mean, this is nothing. This is not going to be a challenge for your robot to pick up. This, however, will be. I would compare it to like this cup, like half full. It's pretty heavy.
In the chat, someone said they've weighed it to be 20 ounces.
Yeah, I would definitely say that's a good number. I haven't weighed it myself, but this is quite a hefty object.
So what's important to remember with that then is students are going to need to be able to pick that up and move it you're going to have to be able to manipulate that. So you're going to have to deal with something as light and delicate as the rings, and also being able to manipulate the wobble goal. Because if you take that wobble goal and move it outside of the perimeter, you get additional points. So just keep that in mind when you're working on your design.
Absolutely.
Because
Yeah, this is
yeah,
definitely a
we've
lot of
also
power.
seen some robots that have picked something heavy up and has extended out a little bit, and then they flip over. So just be careful on your counterweight on your robot as well.
Any other comments concerning the wobble goal yet? Anything else? No? Okay, we're all good. So one thing I noticed just before the stream started is I stacked these all up on the wobble just to get an idea of what would it take to pull this over. So I have 3 rings here in my hand, and they're all offset. And it's got a little bit of a tilt, nothing too major. Another set of 3. So it's pretty stable for holding a lot of these rings. It's not going to fall over even if you're pushing, and I'll just drop it. It's pretty stable. It's got a good center of mass. So I wouldn't freak out too much as far as scoring on it and it falling over and knocking all your rings off. It's pretty stable. We go to another set of 3, so now we're at a total of 9, and that's when we start having problems. But it is standing on its own. It's got a lot of sway, but you're not going to have to worry about all these falling off and descoring themselves.
Hey, Victor, if I can jump in just for a second, there's one thing that I want to make sure everybody knows is we were blessed this year by getting all new perimeters and all new tiles for our field. So please expect a little bit of difference between your gameplay last year on our fields and this year, because we are using brand new tiles. So they're harder. And while he's manipulating that game element on a hard table, um, if we were to use that on our older mats in our field, it would be more spongy. But because we're going all brand new this year, it is going to be more rigid. So just keep that in mind too when you're dealing with your tires and trying to maneuver your robot. You are on all brand new foam tiles this year on our fields. So that may take into some variations in your previous gameplay.
Absolutely. That's a really big point to bring up because I think it's going to make a lot of things more consistent this season. If you guys are using encoders or anything on your drivetrain that makes it a little more accurate, the foam tiles that are a little more stiffer is going to make it a little more consistent. But this wobble goal looks pretty promising. I'm on a hard surface, like he mentioned. I'm on a wooden table, and it's not falling over. On a mat where it might, kind of sink in a bit, I think this will be really stable. I have 2 more rings here for a total of 11, just to see if we could finally knock this thing over. So 11 rings is what it will take all on one side. And this is pretty close to the tip. This will be really noticeable if you're driving. So if I take off 1 ring, 10 will do it as well. 10 is like on the point of no return. It's on the little border of this.
All right, so Victor, what kind of robot design would we be looking at on being able to shoot from the shooting line, to get in the goals, and then also to interact with the wobble goal, and then also be successful in placing the wobble goal outside of the perimeter?
All right, definitely. One thing for this season, it has a lot of dynamic challenges, right? So like he mentioned, we got to shoot, we got to pick up a goal. We got to move around very accurately. So I think something that we all got to keep in mind is staying very modular. So from competition to competition, it's pretty common to adjust your shooter, adjust your arm, whatever it may be. But let's try to go away from having one big design that they all depend on each other, one big structure. We want to keep it modular so it's easy to switch out. For example, like this wobble goal. I could definitely imagine teams holding it up from the top, kind of pivoting to get it over the field and placing it down. That being said, depending on how far away your mechanism from grabbing it to your robot is, I could definitely see that causing it to tip over. So this will be a variable you'll have to play with, along with if you're doing this and you're driving to the wall, slamming it and so forth, you're kind of going to exert a lot of inertia and maybe tip yourself over. So that's a concern. Because we're not going too high, In previous seasons where you go a lot higher, like last season, you would have to have a very low center of gravity. We definitely want that so you guys don't tip over this year, but it's not as big of a deal as before. The rings, we're gonna have to carry a set of rings at least to shoot. In the past, we've only been picking up one game object, so we've gotten away with like a claw. Definitely this season, we're gonna have to intake multiple to be efficient. So definitely that's the biggest thing I wanna get to you guys is keep it modular so you can modify your design and improve and improve and improve. It's not about rebuilding a brand new robot. We wanna improve and tweak those little designs and move forward. Anyone else have any comments what you would try to do for this season?
Well, I saw this really cool intake. It's like way out of left field, right? I didn't know that the rings were flexible as previously shown. So I was really baffled when I saw the intake. It was like a vertical intake where it would like kind of go under the robot and then it'd go straight up. And that just really baffled me. And I was like, I don't think the rings would do that, but you showed that the rings were very flexible. And then it moved into like if you remember from Relic Recovery, how robots would kind of like shoot out and then like they would drop the minerals into the scoring element, the scoring part of the game. So they also did that. That was pretty cool. It wasn't like what a lot of teams are now doing, which is a flywheel.
Mm-hmm.
So
right,
that was really cool.
Anyone else from the panel has any comments about the robot design? Just any thoughts that they're coming to their mind as you guys see the objects?
Yeah, I think intake would be like a really efficient and common mechanism that we're gonna see. And so if like teams like don't have an idea or something, they can go back to previous seasons and look them up on YouTube. And there are some very efficient like intakes from like the Rover Ruckus season, even in the Relic Recovery season. So maybe that's like a good resource for beginner teams to maybe find like get an idea of a basic intake, something efficient and reliable.
Yeah, that's definitely a good point. We're gonna need something that could intake multiple. And I like what Ethan brought up is he didn't originally expect these to be as malleable as they are. So that means that your intake doesn't have to be as it could be a little more rigid. It could be a little more comfortable being stiff versus something that would have to conform to the shape if it was very hard. So let's see if I could just pull up the iPad real quick so you could see what I'm drawing. Start broadcast. All right, I hope you guys could see what I'm seeing. So apologies, I'm not an artist, nor do I claim to be one. So if we just imagine that this square here is our goal or our object that we want to pick up, we definitely want to have a roller somewhere very close to the bottom of it, right? So this would basically be the thickness of the game object. The height will not vary too much from ring to ring. So this is definitely something we could kind of have consistent all around the board. But something I would highly suggest is you're going to have to need more sets of these circles that I've drawn here. But something I would suggest is having this along the same axle or beam. And the reason I say that is so it could pivot, right? So right now, let's just say this is at a 45-degree angle. As it intakes this object, you might want to have it, adjust angles so it could climb up the mechanism. So then this could become a sort of like ramp. So as you intake, it goes in here and it could adjust according to whatever pivot point you have here. Now, of course, make sure whatever ramp you have is not too rigid, that it's not going to cut up anything. Like this could definitely be a point of failure. make sure that this is low to the ground. You definitely want to make sure you don't scratch this area of the game object. And you definitely don't want to puncture it here. You don't want to have this sharp, but you do want to have it low to the ground and flat so you can pick it up very efficiently.
And remember, you're only allowed to possess a maximum of 3 game elements at a time. So be careful with that.
Right, that's definitely something you want to keep into consideration when you're first designing it. Don't have it pick up 10. Don't have it to have the capacity to pick up 10. Have it to have a maximum of 3, maybe 4, and you have a sensor that indicates when you've reached your limit. Now, something that they brought up as well as a flywheel. So for those of you that aren't familiar with a flywheel, we'll start off with just this circle. This would be, the circle that I've just drawn would be the object that would be spinning at a very high rate. And you would want the game object basically next to it. And one thing I suggest is you have a solid barrier between the two. So whenever you're feeding your object, as your flywheel is spinning up, it goes in between these two, it makes contact, and you shoot out. So a flywheel tends to have a lot of complications versus other techniques. I mean, it's definitely going to be the most efficient. For shooting multiple of the sets of these rings, a flywheel will most likely be the best option versus like a catapult, slingshot, or anything else. But there's quite a few problems that could easily come along with it. So just a few of them, just so you guys are aware, is the flywheel is going to have to be at a consistent speed. So that's going to require something like sensors, encoders. So if you don't have a lot of experience with that, it might bring some easy issues. Every time you shoot, you're going to lose speed. So you're going to have to monitor that with sensors, create some sort of code to counteract that and keep it consistent. Another thing that I've experienced in the past is that this axle that I drawn here, I'll draw it in blue. It's going to be spinning very fast. So whatever bearing you have, whatever's holding this object in place will get worn down over time. So if you're making this in the center of your robot, you might need to maintenance it or take care of it every so often, replace bearings, make sure everything's tight. Definitely make sure you, like I said before, have it modular so you're able to adjust it. There's going to be a lot of vibrations, so your whole robot itself, make sure you keep everything nice and tight. You frequently check all your screws, all your bolts. I suggest you use Loctite this season. For those of you that aren't familiar with Loctite, it's just a lock threader. So you could think of it as like a really weak adhesive for your bolts or screws. And what it'll do is it'll do its best to prevent things like vibrations from making those come apart. If you guys are using that, make sure you use blue Loctite, which is removable, and not red. That's basically super glue. Okay, just double checking the chat.
Yeah, we see some great coaches in here, Mr. Sanchez and Mr. Gonzalez. Feel free to jump in at any time on this and go ahead with the other question there.
I had a question about the friction of the blocks. So how do you think it would react, like if, not the blocks, the rings, like if the ring is sliding on metal, do you think it'll be able to slide, or do you think it'll be like it'll get stuck really easily?
That's definitely going to come with some experimentation, right? So when you say metal, I mean, I know a lot of these teams are going to be working with extrusion. Some of them are going to be working with old Tetrix, Go Builda. Those things with ridges, anything with holes, has a potential to cause more friction and possibly prevent the object from moving freely in the flywheel. So I would suggest if you're using metal, make sure it's a one solid piece, something very smooth. Like if you're cutting a piece of metal, just have the holes along the place where you're mounting, right? Don't have all these extra holes here where your rings could get caught on. One easy option that I highly suggest would be using something like polycarbonate. You could get it at Home Depot, Lowe's if you need to get it locally. Rev sells it, Andy Mark sells it. And what that is, it's basically plastic. It's a very flexible plastic and it's very smooth. And that's the important part. If you're trying to make sure that you reduce friction so you shoot consistently, I would definitely suggest polycarbonate.
Victor, what kind of RPM are we talking about on a flywheel? I mean, how much RPM are you going to need to generate to be able to hit those goals?
You definitely need something along the thousands, for sure. I haven't experimented with these game objects yet. They're pretty big. And one thing that I've experienced in the past is the more mass that you have, the more that your flywheel will have to. This will probably be like over 9,000.
I've seen a lot of
Yes.
teams actually talking about a good range for the flywheel was actually 5,000 to 7,000 RPM.
Okay.
So
Excellent.
I've seen a lot of teams just talking about, yeah, I have like 7,000 RPM, but they
Well,
just
because
don't
I mean,
have it.
it's important to be effective, but also you don't want your referees running for cover when you go to try to shoot. So I mean,
Yeah.
try to meet us in the middle there. And I think 5,000 to 7,000 sounds pretty good. Victor always, likes more RPM, as I've seen in the past with him. So try to shoot for 5 to 7,000 RPM. I think that's a good number, and see how successful you are. And it's also about not all about RPM. It's how efficient you are in aiming as well. And that's a discussion for your drive team to make sure that they can quickly line up and shoot. And if you can give them consistent RPM, then they can give you consistent targeting.
Absolutely. One thing to keep in mind when you guys are talking about RPM is Ethan was giving a really good range to play with. Keep in mind whatever wheel you have to shoot your objects, whether it's a tire. If you guys are using like the traction tires that come with Rev or something you get on AnyMark, or maybe you just manufacture one yourself and you have a rubbery plastic around, rubbery material, that RPM will change and vary. Sometimes this will also vary on the exact object. Maybe if it's more dense, it'll need less. If it's a lot more flexible or hard, those things are definitely going to change it. But yeah, 5 to 7, I have I guess a bad reputation with overkill. So I would definitely stick with Ethan's recommendation around, you said 4 to 7,000, right?
I said 5 to 7,000 was a lot of the chatter
Okay.
people were saying.
Yeah, so if you guys are constructing your flywheels, it's definitely try to shoot for that range. I see we have a question. Yeah, absolutely.
Mr. Sanchez says the diameter of the wheel also matters for the flywheel RPM, and I think that's true too. I mean, we're assuming that the diameter of the flywheel is a constant, but it's not really. So you know, you're just make sure you balance the size of your flywheel with your RPM. Good point, Mr. Sanchez. Thank you.
Now, one problem that you may encounter that I haven't seen in the past for FTC, but I've definitely seen is if you guys are using a prefabricated wheel. So let's just draw one real quick, or scale this up a bit. So let's just say this is our wheel, and that second ring around it would be your rubbery material that's gripping the tire. Not in all cases, but I've seen teams that have gone so fast that the wheel, the tire around it, actually expands as they spin. So that can mean two things. The first one is, of course, your wheel is expanding if you lose control and it falls off the tire itself. So and then the second would be just you might have failure of your flywheel midway. This could get shifted around or whatever. So I would definitely, if you're using something maybe prefabricated, make sure you have points of contact that secure your tire. I would suggest like maybe 8 points of contact. So every like 45 degrees. I've seen people use zip ties, rubber bands, something, maybe even glue. But you want to make sure that this tire is secure around your wheel, not just the wheel itself. And that'll definitely depend on what tire you're using, the plastic, the rubber material. But be wary of this. If you guys are spinning up a flywheel and you notice, definitely take a look at your flywheel closely and see if is that plastic deforming? Is it stretching? Is it starting to look at a different shape? Like Mr. Sanchez brought up, the diameter does matter. I would try to get something as close as possible to this ring. Of course, if you're trying to stay nice and compact, you want something very small, but I wouldn't suggest doing something this size to spin up the ring. So I would try to stay around the same size, maybe slightly smaller, maybe slightly bigger. And it'll definitely be a big effect. That's something you guys are gonna have to experiment with, which is what's gonna work best for you, not just what you see online, what works best for you. Now, yes. Now, while on the topic of these rings and the variation of them and how to shoot, Jason brought up a really good point that as a programmer or whoever is monitoring the flywheel, it's your responsibility to give them a consistent RPM. So that'll determine like the trajectory of your object. If you want to shoot consistently in the high goal, low goal, whatever you're trying to achieve, you want to ensure that that RPM is consistent. So your driver just has to worry about aiming. One thing I would suggest as the season goes on is you don't let that go down to human error, right? So if you're programming, make sure it reaches that RPM before they have the capability of shooting, right? If you're able to monitor it. Eventually, it would be amazing if we could see some teams utilize the camera. The camera aims and shoots and kind of determines when to shoot and how to shoot. That'll be a big factor. But the first thing is going to be making sure you have a consistent RPM so your drivers could get accustomed to it. And then once you get past that, see if you could use a camera sensor to determine when to shoot. Don't let a human factor ruin your results, all right?
And that's TensorFlow, correct? Using TensorFlow?
Yeah, that's what I would suggest. I mean, I think we have some programmers on here that have had experience with the camera. You guys have any comments? What would be best?
So you could use either TensorFlow or Vuforia. I know that on the shooting target where you have to shoot, there's a vision imager. So you could use Vuforia to scan it and then shoot. I don't know if TensorFlow has it, but if they do, you could do that too. And when you open up your programs, they have FIRST has several sample programs ready for you. And if you use the latest versions, they should be able to scan the new targets. So you'll be able to scan the vision targets. I think TensorFlow should also be able to detect rings in autonomous. So like in autonomous, you have to scan some rings, and you could use that TensorFlow there too.
Yeah, that's a good point, Hugo. I appreciate that. Yes, if you look at pictures of this year's game, you will see visual targets under the goals, and they're not there for just advertising. It's there to help you get your robot lined up using TensorFlow or Vuforia. So please take time to check out those add-ons to your program. They are free, so they are available to all first teams. So please take advantage of that because this year you're going to need to really have efficiency if you're going to score those goals. So use First was very specific this year in outlining that this is the year for augmented reality kind of work, and that's using your TensorFlow and your Vuforia. And there's a lot of sample code out there. And if you have any questions about those specifically, please reach out to us on our Discord, and we'll be happy to answer those questions and point you in the right direction for resources.
I also want to kind of button a little bit. There's also OpenCV as well. OpenCV, I feel, is a lot more lighter and easier to learn, in my opinion, with what I've worked with. I used it for Rover Ruckus, and I also used it near the end of Skystone as well. I felt like OpenCV kind of took a blend of Vuforia and TensorFlow. It kind of made it a little bit easier to understand.
All right,
I
Ethan,
also want
what's the website for that one? I've actually never even heard of that one. So if you can share a URL or something, I'd like to take a look at that one as well.
I can get that for
All
you.
right.
So as you can see, this game brings a lot of new challenges, not just mechanically, but also with your software. So if you guys have any specific questions, like Jason said, bring it up to our Discord so we could definitely address it. And better yet, if you want to start a discussion or possibly a workshop or training, please bring it up to us. We want to educate you guys, help you guys as much as you can, or just bring you guys together. So Ethan, Hugo are very good resources for things such as this nature. I'm not the professional. So we definitely want to have them communicate with you guys what they feel is the best, what they've experienced, because we don't want you guys going in blind and running into a lot of trouble.
Yeah, we don't want any of y'all to become frustrated and just stop using that resource. So if you run into a speed bump, don't even flinch. Get on Discord, post your question, and we will link you up with other teams that are doing it, so that we can be successful as a region.
I also want to butt in. So I know that it's COVID, right? So not a lot of teams can really be there at their school and like kind of build a robot. To test OpenCV, there was there's a team that made a simulation that kind of simulates the FTC SDK. So you can use the camera on your computer or like laptop, and you kind of train your OpenCV pipeline as well. So there's that. There's a lot of simulations for coding, programming. So you don't really have to be there on the field with a fully built robot. So you don't have to worry about, oh, I don't have a robot yet and I can't code program. There's all these simulations online that you download and you run and you kind of link it with your IDE. So there's that as well.
Yeah, that's definitely a great point. We're talking about the game right now, but we have the unique challenge of COVID. So like we just said, we could do a lot of these video trainings, but also Ethan's just coming in with a lot of great resources. He's basically saying that there's always a way to figure it out. There's always a way around it. For those of you that are really into mechanically making this stuff, to getting your hands dirty, you're going to have to move on to CAD, to things like Fusion, so you could start designing a robot. And if you're someone that works with the phone a lot, you're programming, you want to fine tune that stuff. Ethan's helping us find those resources so we could start experimenting early on before we even have a robot built. So for those of you that do not have experience with Fusion 360, we do have some workshops that were available that are posted online, so you guys could start learning on it. A lot of the stuff on Fusion there's going to be a learning curve, especially if you're trying to make your own parts. Luckily, if you're using stuff like Rev or AniMark, they have all their stuff already pre-CADed, so you just download the parts versus trying to design everything yourself. Ethan, do you want to comment on something? No? Okay. I just don't want to talk too much. So right now I'm on the Rev Robotics website, and I'll just share my screen real quick so you guys can see it. So, yes. Okay, I thought I heard someone. So let's just say you guys are going to use this bracket specifically, a 1-inch 90-degree bracket, metal, aluminum. You would look for the part, you would scroll down, and right here, it's already available. Rev, it gives it the part number. It doesn't have the name, so when you download it, I would definitely adjust that. But it comes out as a step file. For those of you that don't have too much experience with CAD, step file is a really good universal format that everyone can download. So once you have the download, you could jump into Fusion and start playing with it right away. You don't have to resketch it or anything like that. And this is for everything.
And for those that want to learn more about Fusion 360, Patriot Engineering out of Mission CISD has been doing a series, and it's on our YouTube channel. So if you'd like to start at the very beginning, they'll walk you through it. Fusion 360 is free for 1 year as a student or an educator. So if you'd like to learn more and to take advantage of that work that Patriot Engineering has done, please visit our YouTube channel.
Yeah, absolutely. We already have those resources available for you guys. And it's not just metal parts, solid parts. You could also do this for wheels. So let's just say this 90mm grip wheel. It's available for everything. So you could go look for every part that you want on Rev, and you could literally download the file and start building it on your computer. So there's definitely a way around the unique challenges we have this season. There's definitely going to be some differences, such as the part that you have on hand might be a little different, might be a bit worn, but everything's here, guys. I don't have too much experience with Go Build, but I'm sure they have those files available as well. So while on the topic of getting around our unique challenges this season, we have Fusion, we have some resources that Ethan brought for code, but the biggest one is you guys have us. Here at First RGV, we'll do anything and everything we can to help you guys out. So if that's creating a Zoom call for you guys to network with each other, if that's providing some sort of training, even if it's something outside of our reach, like Euphoria, we'll contact teams with the experience and knowledge to help you guys out. So don't forget, we're a really big resource that we want you guys to utilize. Whatever we could do, we just need to know. Please just let us know whatever we could do. While on the topic of that, so we do have a new Vista. So it's myself and Andre Adame for FTC. So I have a bit of experience with FTC, so does Andre. So if you guys have several teams, several workshops in a day, we'll definitely make that happen. Now, one thing I'm going to check right now is if you guys could download the game elements. So real quick, I'm just going to go to AniMark. Because I could be mistaken. I know a lot of you guys can't get these
Rev also
parts on hand.
Rev
Yes.
also has the game element step file.
Okay. Let's jump straight on that. Discount elements. There you go. See, Ethan knows everything today. I'm glad we have him on our panel. So we have a ring here. Let's see if they have a file for it. They do. So in addition to just a step file, if you guys can't actually download the program, they have all the details on the ring. Frankly, more details than I would need. They have not just the inner diameter to the outer diameter to thickness, they even have the type of curves around the ring. So if you guys would really like to, you could open these type of files up. And this is what the engineers would be looking at when they're trying to make the part. So everything's going to be here, including tolerances. So the little variation of it, that would be here. See, Ethan's on the ball today. So we have just the basic specifications. You got the CAD, you have the specific drawing. They even provide some explanations for some things you could do. So I just clicked shooter, this little hyperlink right here, the bottom one, took me to this tab, and it shows you some designs you could already try. So we got some requirements like not jamming, shooting from a location, shooting consistently. So there's resources everywhere, guys. We just gotta look for them. So we got some concepts similar to what I've drawn earlier, except I think mine's a little more beautiful. Talks about some of the specific parts to talk about. They even provide a video for shooting part 1, so we could definitely get in the weeds on everything. Final design, what they finally came up with. So if you guys don't have experience, this may be your first season, maybe you're just not sure what to do, definitely look at what these guys have done. They're great resources, it's their parts, they know how to use them. They provide everything, so you could copy it from top to bottom, or just take the concept and modify it to be your own. Provide the parts, the motors. And that's another great point to start off on is what type of motors do you want to use for your flywheel? When you're reaching a lot of these high speeds, you're going to need a motor that could supply that. So going back to the Rev Robotics website, the core hex is not something I would suggest for reaching such a high speed. I would definitely look at the HD hex motors. Let's see. And if you guys don't have experience with the hex motors, they come with different gearboxes built on. So a 40-to-1, these ratios, how they work is for every 40 rotations is one output. So this is a bit stronger than a 20-to-1. So if you're going for speed on your flywheel, you definitely want to click the 20-to-1, and you can see the gearbox looks a bit different on screen. And now this will be better, so you have less gears to manipulate when you're actually creating your flywheel. This is a different variation, so if you have just the motor itself, it looks like that with a little pinion gear on the center. So in the chance that you or your student break the gearboxes, I know I have, you could definitely just buy the gearbox itself, and you could just replace it versus buying a brand new motor. You have the exact specifications here. So the one that's available currently is a 20-to-1 planetary gearbox. We scroll down to that, and it gives us our exact RPM right away. So if you guys already have an idea of where you want to shoot for your RPMs, just multiply this number by the ratio you want to do for your gearbox, and you should get an approximation how fast that wheel will go. Try to overshoot a little bit. So if you're going for 7,000 hypothetically, go a little higher because things like friction or the charge of your battery is going to change that. But you have a really good starting point here.
And Mr. Gonzalez brings up a good point that they have a new variable gearbox that's out now, and it allows you to easily change the gear ratios to test things out. So that's a good point. Thank you, Mr. Gonzalez.
Absolutely. I just hear more toys coming my way. So let's look for that real quick. Yeah, definitely. This is a lot more variation. This is a bunch of stages for different gears. So if we scroll down, yeah, we have a lot of different variations. So the big difference between this and the previous motor that I showed you is this one has, I guess you could say like a staging way to adjust your torque or your ratio on your gear. So this one can get a lot more custom. You could fine tune that gearbox. So in here, they don't have a big ratio like a 20-to-1, but they have a 3-to-1, they have a 4-to-1, they have a 5-to-1. So this would be a lot faster, but you could definitely get that torque by stacking them, which they show in the picture above, where they have multiple stages. It looks like they have 4. So if you guys are building your arm and you need something with a lot of torque, rather than making a bunch of gearboxes externally, you can make something internally built into your motor right on the hub. And so this will reduce space. And these are usually metal gears, so it should be a lot more robust too. So here we can see a diagram of how it's assembled. We have the outer axle, the screws that mount all of the gearboxes together, and look at that. It's just a bunch of stages. So if you need to replace a stage, you need to change the ratio, it's really easy to do that. I would highly suggest you guys start playing with this. Something to keep in mind when you're using these motors is that their encoders are external. So what that basically means is you're not looking at the output of the actual shaft on the motor. So there might be some variation. So it shouldn't be too big, but an external encoder would be a lot better. So for those of you that are programming and you're running into some troubles, this could definitely be a source of it. You're measuring the outside of your motor. So when you start multiplying this by 20, by 100, you're going to see really big variations. So if you can figure out a way to measure that flywheel externally, this could be a light, it could be a magnet sensor. What was the exact name for that, Ethan?
They only have magnetic limit switches.
Okay.
That'd be more for like arm designs.
Right.
So it's the top right there.
Yeah. And that's definitely a source that it could be a source of failure. Is here's a magnet switch, and this is what we would suggest for your arms. So as it comes with 2 magnets. So like for a maximum point and a lowest point, so you don't break your arm. But just keep in mind what I said about that flywheel. You're measuring the external encoder, but it's not from the external shaft, it's from the internal shaft. So that could be a point of failure. You guys got to work around that and find a good solution. For your arm, you could definitely gear it up and maybe not use the encoder, but try using these magnetic limit switches. And I know Ethan has some experience with that, so if you get stuck, he could definitely get in the weeds on that.
Yeah, and Victor, if I can, let me jump in for a minute. I don't really want to get a bunch of emails from your directors on Monday. We're not promoting Rev Robotics, so you don't have to go out and buy, only Rev Robotics or the things that we're talking about. These are just some of the samples. I mean, there's some parts out there from Pitsco, Andy Mark, Go Build a Rev Robotics. I will say though that Rev Robotics is a Texas company, so I am a little biased to them because they are here in Texas. They provide us spare parts at championships and stuff. So we do appreciate our support from Rev. But if you're using Andy Mark or any other like the Go Builder has some really good new products. So please just, if you're in the need of getting some additional motors or parts or anything, please just talk to your department director and see what they can help you out with.
Yeah, it's definitely a great point. I'm showing a lot of these Rev Robotics parts, but that's not what you're limited to. If you guys find better resources like Go Builda, that might be the way to go. So right now I just jumped onto their website just to see what they have available. I know you guys don't see my screen, but I want to make sure I have something to show you guys.
Well, and I think there was a discussion last season because
Mhm.
Go Build It was a little late to the party for the season, and I know there was some discussion about their motors being very robust and they were high RPM, and some of the indications that I got were that they were a pretty strong contender for being one of the best motors out there. So if you haven't checked out Go Build a, check them out. Um, I, the yellow is really not my thing, but it's a it's a good product. And they're fairly cheap too. I haven't looked at their prices lately, but they seem to be fairly cheap.
Last year our team, we did use a lot of Go Builda. The motors that we used were very efficient. We rarely had problems. And not only the motors, it goes to like their channels. Their channels were very strong, robust. Compared to smaller channels such as the Tetric channels. So Go Builda, it's something they provided like very good like parts for your mainframe, something like to give you a good uh structure your base. You know, gives a lot of structural integrity. So that's definitely something to look into along with their motors. I know they have their 5202 series. They have various amounts of RPM motors, like ranging from 100 RPMs to even thousands. So that's definitely something to look into this year as well.
All right, appreciate that, Ismael. And while we're on that note, it is important to note. I want to make sure help me get this word out. Is the Rev Control Hub is a legal part this year. So for those that were looking at it last season, and I was telling you, no, 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 it's not legal. Well, just so y'all know, the Rev Control Hub is now a legal part across the United States. And I do recommend it because the feedback that I've got from the Patrick Michaud out of Dallas, which was one of the beta test locations, is it's flawless, and it eliminates the need for one of your phones. It eliminates a couple cables that can and have come disconnected during gameplay, or you forgot to hook your phone to your hub. So please take a look at that. Again, I'm not endorsing it, but I do appreciate the fact that it eliminates failure. So please take a look at it. It's the Rev Control Hub, and it is a legal part this year.
I wanted to say that the control hub, you also do need an external camera if you are using computer vision systems.
Okay, but that's just a standard USB camera, right, Ethan?
Yeah,
Okay,
they sell those on Rev as well.
okay,
Not plugging Rev, but they also sell those as well.
okay.
You
I
can
think
use basically, I think it's CVO2, any CVO2 USB camera or something like that.
okay, that's good. All right, we are 5 minutes to the end of the session, so if anybody's got any questions or would like to bring up a topic relating to design um, or strategy, please throw it in chat or unmute yourself and speak up. We'd love to hear from you. Well, Johanna, what do you think? Do you think we covered a lot today? She's been
Yeah,
awfully
I think
quiet.
we've covered a lot. There's been a lot.
All right. I think it was
Yeah.
your robot that was doing that little flailing arm thing and beating the top of the lander. Was that y'all? Or I know that was a McAllen team.
That was my team.
Yeah, no, that
Yes.
wasn't me.
Yeah.
Yeah, sorry about that.
Well, it was entertaining. So just remember, everyone, while you're working on your design this year, please, please, please read the manual, read the game manuals. We are going to have a couple. They're already on the schedule, so if you'd like to go ahead and sign up for them, that way you'll get reminded about them before they happen. We do have some Ask the Referee sessions. This year more than ever, it's important that you read your game manuals, that you use make sure you use the legal parts. There are some LG phones that are no longer allowed. They were discontinued off the approved list of parts. That and I think it was Modern Robotics. Their parts, Modern Robotics parts, they're old. The original teams, just be careful of that. They were in the Tetrix kits. So if you've got some Modern Robotics parts, they are being discontinued. They're not legal for gameplay this year. So please make sure you read your game manuals because, like I was saying, with COVID, things are going to be a lot stricter at events this year. We're going to do some pre inspection of your robots using Zoom, and it's just it will make things a lot easier this season. So please, please read your game manuals. We would greatly appreciate it. All right. So with that, Victor, I'm going to turn it over to you to close us out for today.
Great. All right. Thank you guys, everyone, for showing up, especially our panel. I think they've brought a lot of great notes to us, especially on what we could do for prototypes and getting around the issues this season. So I'd like to thank you all for joining us this morning and be safe.
Thank you, sir. Have a good one.